In this video, we will briefly discuss catalysis. So first off, what is a catalyst? Well, a catalyst is a substance that increases the rate of a chemical reaction without itself being consumed. So we're familiar with catalysts on a biological level and catalysts in internal combustion engines. And the nice thing about catalysts is, again, they don't get consumed in the reaction. So for instance, this enzyme that assists in the conversion of maltose into glucose. You notice that nothing really happens to the enzyme, it remains, and it's only the maltose that gets changed. Same thing with a catalytic converter in a combustion engine. A catalytic converter is just semi-precious metals in a certain fashion, and they assist in the reaction of certain pollutants in order to convert them to things such as nitrogen and oxygen. Now, these catalytic converters don't themselves get consumed, which is very nice because they're pretty expensive. It's only when you add certain other compounds, such as lead, that actually damages them. But in the intended reaction, nothing really happens. So, why do we need catalysts? How do catalysts work, more specifically? Like we said, we need to speed up a slow reaction. So, for instance, the reaction of hydrogen peroxide decomposing into water and oxygen. So how do catalysts work? Well, in this example, we're taking the decomposition of hydrogen peroxide into water and oxygen. This is a very straightforward reaction. It occurs spontaneously. It's just extremely slow, and that's because there's a high activation energy that needs to be overcome. So how do we overcome it? By adding a catalyst. And that catalyst is going to lower that activation energy. Now, one common catalyst is to add something such as potassium iodide, and it's actually just the iodide ion that performs the catalysis. So in this case, you add iodide, you form water and hypoiodite, and that hypoiodite goes on to react with another hydrogen peroxide molecule. Now, if we add all these up, we notice that, well, we don't see the hypoiodite. It's an intermediate. And we actually don't see the iodide. So with catalyst, we have a much lower activation energy. And again, it should be noted that the iodide is the catalyst. It's not used up in the reaction. You put it in and you get it out in the end. So it's very important to differentiate this catalyst that we added as a reactant in the first step, and that was also reproduced or showed up again as a product in the final step, as opposed to the hypoiodite. That's an intermediate. It was a product in the first step that was reconsumed as a reactant in a subsequent step. So the lesson here is catalysts are not used up in a reaction. They will show up as a product, as they did as a reactant, and they lower the activation energy of a reaction in order to speed it up.